Hello, 11th graders. So we are finishing up our part of this unit that deals with sequences and series. So kind of like what we did in our last lesson, where we talked about how to do the things mathematically, and then how to take those mathematical concepts and apply them in certain circumstances or situations. That's what we're going to be doing with these notes as well. So we're going to have two sections. One's more of like a mathematical, do you understand the concept of what's going on here? And then the second day is going to be why do we care about this? What are the applications here? Which is actually probably one of your more applicable. I mean, I think I say this about every application of mathematics that we do, but it's a very applicable thing that we use in everyday life if you deal with finance and banks at all in your life, which I'm assuming all of you are going to at some point. What we're going to learn about interest rates and annuity and amortization are all very, very useful to you. Okay, so let's talk about the mathematics. We always hear the terms sequences and series together in a sentence, but so far we've only learned about sequences. Sequences are a list of numbers that have patterns and they follow that pattern. And we've learned about the two different types of sequences. We've got arithmetic sequences where we've got repeated addition versus geometric sequences where we've got repeated multiplication. Now we're going to talk about series. The only difference between sequences and series is that sequences are a list of numbers and series is the sum of a list of numbers. Sum meaning addition, S-U-M. So a series takes a sequence and adds up all of the terms. You can go infinitely, what happens when we add up all of the terms of the infinite sequence, but that is not what we're touching in this class at all. We will only be talking about finite series. In other words, from this term to this term, if we add them all up, how many total is that? And you're going to see in some of our word problems here why we talk about it. Okay, so I want you to write down here series. A series is the sum, that's S-U-M, sum of a sequence. We could make it a lot more complicated and go into a lot of different things about it, but really boil it down, that's what a series is. A series is the sum of a sequence. And so you'll see a list of numbers when you'll see, like we can go down below to our notes, you'll see a list of numbers like here in example 3 where we're adding them all up. Now we could still think of it and picture it with a comma in between and try and figure out what is the pattern from term to term to term. But then we take all of those terms and then we add them together. It could also be a repeated subtraction or it could be an addition and then a subtraction if it's a geometric sequence. Remember how we had like sometimes the signs flipped where it was a positive term and then a negative term and then a positive term and then a negative term. So in that case, the series of that would be the sum and then the difference and then the sum and then the difference. So there's a lot of different ways that it can be applied, but that's pretty much it in terms of what it is as a thing. Okay, so we have this really crazy notation for a partial sum or a sum, a finite sum. And it's called sigma notation because we use sigma. Whenever you watch a TV show and they're just like writing a bunch of things on a board and you're like, wow, they look really, really smart because they're like writing all these mathematical terms, you'll see this on there almost every single time. And it's just a series notation and that's all it is. It just looks fancy. So this is sigma. You will probably be practicing making this sign a bunch of times. I know I did when I first learned about it. So what you have is you have multiple parts. You see this, and we'll say S sub, we'll do N. So the sum of a certain number of terms, S sub N, is the definition here. You'll see something like this. And then we'll say to the K. And what that means, we'll do N equals K. What that means, n equals 1 at the bottom there, is that we're going to start with the first term. So n equals 1 means we start with the first term. N is your a sub n, a sub 1, a sub 2, a sub 3, a sub 4, right? That's what n is. And then n equals k is where you stop. So if we're talking about the sum of the first 30 terms, you're going from 1 to 30 when you're looking at that sigma notation and the numbers on the bottom and then on the top. So it means that we're starting at that number at the bottom and ending at that number up top. If we were finding the sum of all of the terms between the third term and the fifth term, it would be 3 on the bottom and then 5 on top. So that's what those numbers mean. And then we've got a sub n. Now, so a sub n is how you define the sequence, and s sub n is the sum of those terms of that sequence. So that's going to be a sub 1 plus a sub 2 plus a sub 3 plus all the way to a sub k. So whatever I said to you in this definition, pause for a second and rewrite what I said in terms of, because this is crazy new notation. If there's anything in here that you don't understand, now is the time to write down, right? S sub n means the sum of n number of terms. S sub 10 is the sum of 10 terms. They don't necessarily have to be the first 10 terms. It could be any 10 terms, sequential 10 terms. N equals 1 is the number or the term number that we start with. N equals k is the term number that we stop with. A sub n is the definition of the sequence, in other words, the equation of the sequence. And then all it means is that you're adding up those terms together. So we're going to we're going to find the sum of the first 13 terms of the sequence, a sub n equals. And so we're given a definition for this sequence, and we're told we want to find the sum of the first 13 terms. So we're going to just turn this into sigma notation just to practice. So if we want to write down the partial sum, we've got sigma right there. We start with, and since n, it's a sub n, so we have n equals 1 at the bottom, because we're starting with the first 13 terms, and then we end at 13. We don't typically do n equals 13 up top. We just write 13 up top. And then all you have to write next is the definition of the sequence. So 1 over 3n plus 1. And that's all you do. And that's a sub 1 would be 1 over 3 plus 1, so 1/4 plus. And then n equals 2 would be 1 over 3 times 2, which is 6, plus 1, which is 7. So 1 over 7 plus. And we'll do one more term just for you to kind of get the idea. Actually, let's do ... and do the 13th term. So 1 over 3 times 13 is 39, plus 1 is 40. So 1 over 40. So it's that combination of that idea of being able to plug in n's and find the terms in the sequence, but then what you're doing is adding them all together. Okay. Next one, we're going to find the sum of the 3rd through the 10th terms. So that's sigma. Ooh, not my best sigma. Of n equals 3 all the way up to 10 of the sequence. Oh, not n, because notice here it's a sub k. So I do that all the time where I start with n, because that tends to be the default, but it's not always the case. So it's k equals 3 all the way up to 10. And then we just have to write the definition of the sequence. And that's k plus 1 over k. So if we were to try and think about, well, what does that mean? That's the 3rd term. So 3 plus 1 is 4 over 3. Plus the 4th term, which is 5 over 4. Plus, and then the 10th term, which is 11 over 10. And that's all that means. Okay, the next one, the last one. Find the sum of the first 12 terms of the sequence, and it just tells us a list of numbers. We don't know what the definition is, so we have to find out what the definition is. We have to find out what the equation is. Is it geometric? Is it arithmetic? I can see that I'm going to be adding the same number every time, and I do a few calculations, and I realize that my common difference is, here, we'll do it over here. The common difference is 8, and a sub 1 equals -5. So if we do a little bit of our arithmetic sequence knowledge, which is in your formula packet, that's a sub n equals a sub 1 plus n minus 1 times the common difference. I might want to combine like terms just because I feel like with sigma notation, I want to make sure that things are as concise and precise as possible. And this just seems a little messy. And so I am going to, because of my own personal desire to have this look nicer, distribute the 8 and then combine like terms. So that'll be 8n, and then that's -8 with a -5 is -13. So that's the definition of this sequence to the left. And now I want to talk about the sum of the first 12 terms. The sum of the first 12 terms would be from n equals 1 up to 12 of the sequence 8n minus 13. Okay. So that's kind of your first introduction to sigma notation, going back and forth. We're going to do a few examples, and then we'll learn a few formulas. These notes are long today. I'm sorry, I'm trying to explain this efficiently and effectively, which means sometimes it takes time. Okay, write each series in full. We're not asked to calculate it, we're just asked to write it out. So we're looking, when you type it into the equation editor, it looks like this, but it's still that same idea, even though the 5 and the I equals 1 is to the right of the sigma, it's still that idea of one being on top and one being on bottom. So from the first term to the fifth term of I to the fourth, and it says I equals 1, so we're going to do 1 to the fourth, 2 to the fourth, 3 to the fourth, 4 to the fourth, 5 to the fourth, and we're going to add them all up. And we don't have to calculate it at all, so we're just writing it. So it's 1 to the fourth plus 2 to the fourth plus 3 to the fourth plus 4 to the fourth plus 5 to the fourth. Series is really where sequences become applicable. Sequences are like fun and games, more analysis of the mathematical side. It's like a puzzle is what I mean by fun and games, where you see a pattern, you're asked to recognize the pattern, you're asked to predict the pattern or define the pattern. Now, when you're talking about defining the pattern, you're like, okay, well, why were these numbers occurring? Were they occurring because of a bank loan? Were they occurring because of a pattern that I see and I want to be able to know how many seats are in the auditorium based off of this pattern that I see? So you normally don't just want to know what the pattern of the numbers are. You want to have them interact together in a way. Okay, this one. We're starting with 3 and ending with 7, and it's r, so 3 to the r. So that's going to be 3 to the third power plus 3 to the fourth power plus 3 to the fifth power plus 3 to the sixth power plus 3 to the seventh power. This is a geometric sequence. Whereas this guy over here, we know it's a geometric sequence because your exponent is your variable, right? It's an exponential equation, versus over here, it is not an exponential equation, it's a quartic equation, and there's no name for a sequence that is a quartic because it's to the fourth power. So A here is neither geometric nor arithmetic versus B, which is geometric.